Hey everyone, welcome to another video. In the previous one, we looked at what the index laws are and how you can use them and what their definitions are. So in this video, we are actually going to look at 10 different examples on how you can apply the index laws in order to simplify a given expression, including exponentials. So the very first one that we'll look at is a problem or an expression that looks something like this. 3 multiplied by a square root of 3. Right? So if you're asked to simplify this so that it's written by one base and with one exponent, then the very first thing that we'll have to do is that we'll have to rewrite this expression using exponential. So we'll rewrite 3 to the power of 1 because every exponent, every number that has nothing on the top has the exponent of 1 multiplied by, then we'll rewrite this into the exponent as well. Now just like the index law states, that this will be rewritten as a half. Now, if you recall that one of the very first index laws that we looked at states that if the base is the same, which in this case is, so we have a 3 here and we have a 3 here, then we can rewrite it, then we can write a 3 there, then you can add the two exponents of the two expressions. So that means that because they both have a base of a 3, we can then add the exponents. So it's 1 plus 1 half. Which then you do a 2, and now since that would be a 2 as well, plus 1, and then it's a 3 over 2, which is 1.5, right? So that's 1 plus half, 1.5, so that's perfect. Then we can rewrite this as 3 to the power of a 2. Now, of course, you can also leave it like that, but if you would rather have this written as an expression like that one, then you can also rewrite this. Again, if you remember, the index law states that you can rewrite this as 3 to the power of a half, and then brackets, and then raise this to the power of a 3, which then translates into a square root of 3 raised to the power of a 3. So that is your simplified expression starting from this one. Then this can be rewritten as this expression. So that's the first example. Then we'll move on and take a look at another example. Now let's say instead of the first one, you are now asked to simplify a rational expression that looks like 1 divided by 9 multiplied by a square root of 3. Now, in the first view, just like I said earlier, that we can only add the exponents as long as the base is the same. In this case, it's not, right? So there's not much we can do with the numerator because it is what it is. So we'll just write that, then 1 divided by. Now a 9 can be rewritten as 3, can't it? Because 3 times by 3 is 9. And then 3 times 3 can be rewritten as 3 to the power of a 2. So that means that we can then rewrite this as 3 to the power of a 2. Multiplied by, just like before, we'll rewrite this as 3 to the power of a half. And then again, now, since the base is the same, then I'll write 1 divided by 3. Because the base is the same, that means that I am allowed to add the two exponents together. And then that's exactly what I'll do right here. So 2 plus a half, that is then 3 over 2. Oops, sorry, that is not 3 over 2, that is 5 over 2. Sorry about that. Then we'll write 3 to the power of 5 halves. And then again, just like using the previous definition that we did right here, I can then directly write this as the square root of 3 brackets raised to the power of 5. And that's it. But now let's move into an example where we have variables introduced into the expression. So let's say that you are now asked to simplify an expression that states that 3a cubed multiplied by 9a squared. Now, even though you have variables in this expression, it does not change the process or the laws in any other way. So you treat them just like you do with A very simple expression. The first thing that we'll do is that we'll have to rewrite this, because we know that every time you get an expression where it says 3a cubed, it means 3 multiplied by a cubed multiplied by 9 multiplied by a squared. So they're all being multiplied together. So that's a good thing. And then what we'll do now is that we will group the numbers together and we'll group the variables together. Why? Because like I said earlier, the only way we can add the exponents to simplify an expression is that the base has to be the same, right? So we'll write 3, and I'll rewrite 9 as a 3 squared, just like I did before, multiplied by a cubed, multiplied by a squared. So now you see you have two groups, right? You have the group 1, and then you have the second group. These two have the same base, these two have the same base. So I'll start off with this one. So 3. Now I can add the exponents together, and do not forget that every time you have a number written just like that, it has an exponent of 1, right? So it will be 1 plus 2, and that is 3. And then now you have a, so I can just rewrite a, because the base is the same. I can add the exponents. So 3 plus 5, 3 plus 2, that gives me 5. Now you can of course leave it just like that, but many times you can also rewrite this as, because 3 times 3 is 9, and 9 times 3 is 27. So we just write 27 times by a to the power of 5. But that's like a more simplified expression as compared to the one in the beginning. So that's how you treat variables if they're given with your exponents. But now let's take it a step further and let's introduce variables in the exponents itself. So let's say that you have an expression that looks something like 21 times by a to the power of a 9 divided by 7 times by a to the power of a 2. Now, the very first thing that we'll do is that we can, the first things first, because just like we did earlier, that everything is being multiplied with each other, right? So 21 times by a to the power of a 9, 7 times by a to the power of a square. What I'll do now is that I'll break up the fraction. So I will end up writing 21 divided by 7 multiplied by a to the power of a 9 divided by a to the power of a square. And the reason for doing that is because now you'll see that these are not numbers and these are just variables. So we know that 7 times 7 3s are 21. So that means that this fraction can actually be simplified to merely 3 multiplied by. Now I'll put a bracket just to highlight that we are evaluating this fraction, is because a to the power of a 9. Now one of the index laws states that if you have a number, you have an expression in the denominator, I can actually multiply it with the numerator given the fact that I put a negative on the exponent. And that's exactly what I'll do. I'll then just put in -2 because I'm moving it from the denominator to the numerator, hence the -2. And once again, since the base is the same, so I'll just write a, but now it's 9, and let's remember that it's 9 plus minus 2, but a plus multiplied by a negative is a negative, so then this becomes 9 minus 2, and then you get a 7. And then your expression becomes 3 times a to the power of a 7. So you see that you can simplify from an expression that looks something like this to an expression that looks something very simple, like that. So let's take our fifth example. Let's say that you have an expression that says that you have a -4 times by a, which is raised to the power of a -2, and all of that is raised to the power of a 3. Now, just like once again, just like we did earlier, that we will break up the bracket, and the way we'll break up the bracket is we'll say -4, because just like the exponent, one of the index laws states that if you have an expression inside a bracket and the bracket is raised to a specific power, then that power applies to every single variable of that expression, as long as they are being multiplied or being plus within the brackets, right? So that means that I can rewrite this as minus 4 to the power of a 3 multiplied by a to the power of a minus 2 to the power of a 3. And if you have something in the brackets, then we have to multiply the exponent with the exponent of the number within. So that's 4 is raised to the power of 1. That means that I will have to rewrite this as negative 4. The 1 will be multiplied by 3. But I'm not going to get rid of the bracket because we have a negative there. So you just have to keep that in mind, because the negative will also be multiplied 3 times with itself. And I'll speak on that in a minute. On the other hand side, you have an a to the power of a negative 2 being multiplied by the 3. But now, since this negative is on the power, therefore, you will not convert that into anything else, because now you're only multiplying the numbers together. So we know that a plus multiplied by a negative, that is a negative. But a negative multiplied by a negative, that gives you a positive, right? So now, if a negative is being multiplied by itself, because what we're doing is that we're doing minus 4 times by minus 4 times by minus 4. And keep that in mind that it's not 4 that is being multiplied by itself 3 times, but rather it is negative 4 being multiplied by itself 4 times. So we'll actually have to multiply the negatives as well. What we can do now is that we know that 4 times 4 times 4, that is 64. So we'll write that. A negative times negative, that's a positive. And a positive times a negative, that's a negative. That means that then you end up getting a negative 64. So you can do negative 64 multiplied by a to the power of a negative 6. But it's not really simplified yet, is it? Because I will write a negative 64 because this expression has a negative in the exponent. Therefore, that means that this one has to be moved to the denominator and being raised to the power of a 6. So then your solution will be negative 64 divided by a raised to the power of 6. Now let's move on to another example. Now let's say that we have an expression that says 9 to the power of an 8 divided by 3 raised to the power of a 2 minus 8. Now, once again, previously, if you remember, I'll actually go back. In the second example that we looked at, you have to keep that in mind that the only reason that we could divide the two bases together was because there was no power on them, right? So therefore, I could break up this expression, and then I got 21 divided by 7, which then is 3. But now in this case, you'll see that we have the two numbers, but they both actually have a power on top of it, right? So that means that firstly what I'll do is I'll rewrite this expression so that we get a horizontal expression instead of the fraction that you see now. So 9 times 8 multiplied by 3. Now I have moved the bottom expression to the numerator. Just like the law states, I will have to change the sign on the power. So it will then become negative 2 negative minus 8. Now I cannot multiply the two exponents together because the base is not the same. Hence I will then rewrite 9 just like we did earlier as 3 squared. And then since it already has a power of an a, so the a comes to 2 times by 3. That would then become a negative 2 plus a. Now, luckily for us, the base is the same. So that means that then you do 3, and then we'll actually do it right here. So it's 2a plus minus 2 plus a, right? So 2a, that would then be negative 2 plus a. Then you end up getting 3a negative 2. But that means that your exponent then ends up becoming 3 to the power of 3a negative 2. And that is then your final expression that comes from an expression that might look like this at the beginning. So you see, so you have to keep this in mind, that you have to always remember that if you have a rational function or a rational expression that looks like this one, make it horizontal by moving the numerator to the top. Because as long as they're being multiplied together, and then as long as you have the bases are the same, then it gets very easy for you to simplify. But if you don't do these things, then it will be very difficult for you to simplify an expression that started off from here and then ended up looking like that. Then we'll look at another example, number 7. Now let's say, and this is a very easy one, but let's say you are asked to simplify multiplied by 4 to the power of 8. Now that's 4 to the power of a 0 multiplied by 4 to the power of 8. Now the index law states, and this is a very important rule for you to remember, is that anything raised to the power of a 0 is equal to 1. That means that 4 to the power of 0, that is 1, multiplied by 4 to the power of 8. And now since it's 1, so we can actually just then get rid of it, and then you already have 4a. Now it looks very simple, but a lot of people, they actually forget that for any base to the power of a 0, that is equal to 1. So that's also one of the important rules or the definitions that you have to remember. And then another example that we'll look at is very similar to this one, but instead of 0, let's say you wrote 4 times by 4 to the power of 8, right? And then now there are 2 ways to do it. The first one is that if you're asked to simplify it, then it's very simple, because just like we've been doing so far, since the base is the same, so you just add them together. So it's 1 plus 8. But what if someone asks you to simplify it even further than that expression that you see on the screen? Then the thing you have to realize is that 4 can be also rewritten as an exponent. How? Because 2 times 2, which is 2 squared, that is equal to a 4. That means that what I'll do now is that I'll say 2 to the power of a 2. I'll put the brackets there, and then 1 plus a. And now since the 2 will be multiplied with the entire expression, you end up getting 2 plus 2a. There we go. Because a lot of times, in many exam papers or in questions, you are asked to simplify the expression to the lowest base value. And then many times people just simply stop at 4 to the power of 1 plus 8. But you have to remember that if you can break down a number even further into exponents, then you should do so. Because it's a bummer if you lose marks in the exam just because you forgot to break it down even further, right? So there's that. And then another example that we'll look at is, so let's say that similar to the expression that we looked at before is 3 times a to the power of a negative 4, b to the power of a square raised to the power of a 3. Now, just like the index law states that if you have a number outside of the bracket, then it applies to all the numbers within that expression. Then that means that we'll have to rewrite this as 3 to the power of 3 multiplied by a to the power of 12 multiplied by b to the power of 6. 12 because 4 times 3, that's 12, and 2 times 3, that's 6. And now, of course, I can just rewrite this as 3 cubed b to the power of 6 divided by a to the power of 12. To make it even neater, then you can just say 3 times 3 times 3, 3 3s are 9, 9 3s are 27. So I can just rewrite this as 27 b to the power of 6 divided by a to the power of 12. Now I cannot simplify it any further. Why? Because none of the bases are the same. So this is the simplified version that you can get. Now, the very final example that we will look at is, let's say you are asked to simplify an expression that looks 1 divided by 4, 1 plus n. That's it. And you're asked to rewrite it without the rational fraction, without the fraction. And again, it's very simple, just like you've been doing it before, that if you're trying to move a number from the numerator to the denominator, then you just say 4 to the power of a negative 1 plus n, and then you end up saying 4 to the power of negative 1 negative n, and that's it. And that is all for the using the index laws in different problems. And these were all the examples that we wanted to look at for this video, and I really hope you enjoyed it. And if you did, then do remember to subscribe to the channel, and let us know in the comments below if you guys have any questions or any doubts that you would like to be clear. And stay tuned for our next videos. Thank you, and have a nice day.